Alright guys, welcome back to Underground Science, and in this video we're going to be talking about pyrimidine synthesis. But since we already talked about synthesis, specifically in this video, we're talking about the drugs involved, okay, in this pathway. Because there are certain drugs that inhibit certain enzymes that we need to know. That's high yield. Alright, so let's start over here. How do we get carbamyl aspartate, right? So we took carbamyl phosphate and we converted carbamyl phosphate into carbamyl aspartate via the help of aspartate carbamyl transferase, right? Aspartate carbamyl transferase. Then from carbamyl aspartate, we made dihydroorotate via dihydroorotate. Then from dihydroorotate, we made orotic acid via the help of dihydroorotate dehydrogenase. Okay? So this enzyme right here, dihydroorotate dehydrogenase, again, that helped us make orotic acid from dihydroorotate. So if I take this enzyme, I'm going to bring it out here because this enzyme is very important because, right, this enzyme is inhibited by leflunomide. Leflunomide. Okay? So that's the first high yield drug we should know. Actually I'll just draw it right now, but what we should know is that leflunomide, right? Let's draw a different color. Leflunomide inhibits dihydroorotate dehydrogenase. Okay? So we know that now, so let's keep on going. So we're at orotic acid. And now from orotic acid, remember, we made OMP with the help of PRPP molecule. Right? Remember the phosphoribosyl pyrophosphate got added into the reaction and we got the help of orotate phosphoribosyl transferase, right? So now we made OMP. Okay, so let's go down to OMP. Okay, so now from OMP, we went to UMP via OMP decarboxylase. Okay, then from UMP, remember we went to UDP, so this step, right, OMP all the way to UDP, and then another critical enzyme is coming up, where we went from UDP to deoxy-UDP. So to do that, we use the enzyme ribonucleotide reductase, right? So this enzyme ribonucleotide reductase, again, is inhibited by a certain drug, and that drug name is hydroxyurea. Okay, hydroxyurea. So again, this drug inhibits ribonucleotide reductase. Alright, so we got that, right? Hydroxyurea inhibits ribonucleotide reductase. Okay, sweet. So let's keep on going. So after we make deoxyuridine diphosphate, we make deoxyuridine monophosphate. Okay? So then remember, from deoxyuridine monophosphate, we went ahead and made deoxythymidine monophosphate via the help of thymidylate synthase. So we're going to go ahead and circle thymidylate synthase because this is another enzyme that we should pay particular attention to because we have a drug that inhibits this enzyme. And this drug is 5-fluorouracil. Okay? 5-fluoro. Hopefully I can spell this right. 5-fluorouracil. And we should know the prodrug of 5-fluorouracil, which is capacitabine. Okay? That's definitely pronounced wrong, but 5-fluorouracil's prodrug is capacitabine. Okay? And that means that capacitabine, and I'm probably pronouncing it wrong, but this capacitabine molecule or prodrug gets converted into 5-fluorouracil. For example, we can take the liver, right? So the capacitabine itself will go to the liver, turn into the active form of which is 5-fluorouracil, and then 5-fluorouracil can go ahead and inhibit thymidylate synthase. Okay? So we got that drug down. Now, this same step that we're at right now, again, thymidylate synthase did what? It converted DUMP to DTMP, okay? But what else happened here? We had to use 5,10-methylene tetrahydrofolate and convert that to dihydrofolate. But to get this 5,10 methylene tetrahydrofolate back, we need to convert dihydrofolate to tetrahydrofolate, right? So that we can convert tetrahydrofolate back to 5,10 methylene tetrahydrofolate. So how do we convert dihydrofolate to tetrahydrofolate? We use dihydrofolate reductase. Well, there's multiple drugs that inhibit this enzyme, dihydrofolate reductase. Okay, so let's list them out. So one drug that inhibits this, so these are, we'll write it down later, like as in inhibiting dihydrofolate reductase, right? So the first drug that we should know is trimethoprim. All right, another drug that inhibits dihydrofolate reductase is pyrimethamine. All right, so far we have trimethoprim, pyrimethamine. Another drug is aminopterin. Hopefully I'm pronouncing that right. Aminopterin. All right, so that's 3 so far. Trimethoprim, pyrimethamine, aminopterin. And let's go another one. Another drug that inhibits dihydrofolate reductase, or it's not, well, we wouldn't really count it as a drug. We can just say in general that, hey, let me do this in a different color because it's not really a drug. We can just say in general that if you're deficient in folic acid, so if I just write folic acid and a bunch of down arrows showing that deficiency in folic acid, that can, slow down the activity of dihydrofolate reductase, leading to, less of this cycle above happening. Okay, so far we have trimethoprim, pyrimethamine, aminopterin, decreased folic acid or folic acid deficiency can inhibit dihydrofolate reductase. And the last one that we should know is methotrexate. Okay, so there's a bunch of things or a bunch of drugs that inhibits this enzyme. So we can start from the top. So this is an antibiotic. Okay, pyrimethamine is a anti-parasitic. Aminopterin, right? Well, first of all, this is spelled wrong. So let's take out that E. Sorry, my bad. So aminopterin, right, is we can just basically label this as an like an anti-cancer drug because you can use this in chemotherapy. All right, and then when we go on to folic acid deficiency, that's really nothing, just showing that okay, if you're deficient in folic acid, that may lead to the inhibition of dihydrofolate reductase. And then last but not least, methotrexate is also an antibiotic. All right, but when I say antibiotic, right, what I'm referring to as is that methotrexate has microbial properties, right? So you can use it for certain bacteria. However, another main function of methotrexate though is again anti-cancer, okay, because you can use it for chemotherapy. All right, so that's basically the drugs involved in the pyrimidine pathway. Next, we'll go through the drugs involved in the purine pathway or the purine synthesis pathway. All right, so I hope this video helped you guys, and I hope to see you guys in the next video.